traffic, Pulsar 500 Sierra Sierra, departing runway 16.
Taxiing out for takeoff in your own personal airplane. It's every pilot's dream. The freedom to fly anytime you like, anywhere you like, without the limitations of renting, borrowing. This is what the dream of flying your own airplane is all about. Unfortunately, for the past several years, personal aviation has become increasingly expensive, complex, and restrictive. Many pilots have stopped flying. Worst of all, many pilots have given up on their dream of owning an airplane. Well, some dreams will never die. Welcome to the world of the Pulsar. Welcome to the world of fun, practical, and affordable flying. Welcome to the world where the dream of flying your own airplane can become a reality. Aero Designs in San Antonio, Texas, developed the Pulsar for one reason: to provide you an economical and practical way to get off the ground and into the air. The Pulsar is an easy-to-build, fun-flying, and extremely attractive kit-built airplane. It is an airplane that will meet all of your expectations about how a personal airplane should be engineered and how a personal airplane should perform. The Pulsar is designed to give you maximum flying pleasure regardless of the mission being flown. If the mission for the day is a local fun flight, the Pulsar is superb. Takeoff rolls are short, climbs are quick. If any low-altitude turbulence is encountered, the relatively high wing loading and tapered wing design of the Pulsar act well to smooth out the bumps. On windy days when other lightweight airplanes are in the hangar, the Pulsar is out flying. Once at sightseeing altitude, the Pulsar is a pure joy to fly. The Pulsar combines high levels of stability with high levels of maneuverability. The pilot enjoys responsive but not overly sensitive control forces. Workload is low, enjoyment is high. As a recreational flyer, the Pulsar is extremely efficient. At reduced power settings normally used for local flying, the Pulsar uses fuel at the incredibly low rate of 3 gallons per hour. When it's time to land, the Pulsar shows its good manners in the traffic pattern. Typical approach speeds are between 55 and 65 miles an hour. Even at these low speeds, handling is crisp and responsive. At maximum landing weight, landing distances of 800 feet are possible, 400 feet if flying solo. Effortless maneuverability, outstanding efficiency, docile landing characteristics. The Pulsar is the perfect fun-flying airplane. But in addition to being a local fun flyer, there's another mission where Pulsar excels as well. The Pulsar is also an outstanding cross-country performer. Pilots love to travel, and the Pulsar was designed for the traveling pilot. Whether flying to the nearest airport for lunch or flying 1,000 miles in one day, the Pulsar is always fast and efficient. Even at reduced power settings, cruise speeds of up to 140 miles an hour will be obtained. With a service ceiling of 15,000 feet, smooth, cool altitudes can always be reached for comfortable en route cruise. And with a full fuel range between 500 to 600 miles, the Pulsar is an excellent airplane for longer distance flights. If the destination is a larger airport, operations there are no problem in a properly equipped Pulsar. With good airspeed flexibility, approach speeds can be kept high. This allows you to smoothly fit in with the traffic flow, a feature other pilots and controllers will certainly appreciate. Pulsar, a perfect personal airplane for having fun and simply enjoying the thrill and excitement of flying your own airplane. Pulsar, a perfect personal airplane for practical, economical, and fast cross-country transportation. The Pulsar is truly a no-compromise airplane that you can build and fly. Now, let's take a detailed look at the two models of the Pulsar that are available from Aero Designs. Depending on your choice of engines and desired level of aircraft performance, two versions of the Pulsar are available: the standard Pulsar and the Pulsar XP. First is the standard Pulsar. The standard Pulsar is an excellent combination of high performance, lightweight, and low cost. The airplane combines high aerodynamic efficiency along with the economy of the two-cylinder, two-cycle Rotax 582 aircraft engine. The standard Pulsar is currently the highest performance kit aircraft available today using the Rotax 582 engine. The Rotax 582 is a two-cylinder, two-cycle aircraft engine with dual electronic ignition. The engine is liquid-cooled and is lubricated by a mixture of fuel and oil. Either premium unleaded auto gas or 100 low-lead avgas is acceptable. A 12-volt, 15-amp electrical system and an electric starter are standard. As installed in the Pulsar, the Rotax 582 develops 66 horsepower. With the Rotax 582 developing full power, takeoffs require only 800 feet. Initial climb rate is 1,000 feet per minute. At cruise altitudes, the standard Pulsar really shows its efficiency. Cruise speed at 75% power is 130 miles per hour. At this speed, the Rotax 582 uses only 3.8 gallons per hour of fuel. The standard Pulsar can carry full fuel and 400 pounds of cabin payload 500 miles without refueling. Very impressive numbers from a very impressive airplane. For even more performance, the Pulsar XP is available. The Pulsar XP combines the efficient Pulsar airframe with the more powerful Rotax 912 aircraft engine. The Rotax 912 is equipped with dual electronic ignition, a 12-volt, 24-amp electrical system with an electric starter and provisions for installing an engine-driven vacuum pump. The engine has a separate oil system for lubrication. Cooling is provided by a combination of liquid-cooled cylinder heads and air-cooled cylinders. The Rotax 912 uses either premium unleaded auto gas or 100 low-lead avgas. As installed in the Pulsar XP, the Rotax 912 develops 80 horsepower. When flying the Pulsar XP, the additional power of the Rotax 912 is immediately evident. Runway acceleration is rapid. Takeoff distances of 800 feet, 400 feet when flying solo, can be expected. With the extra power of the Rotax 912 engine, the Pulsar XP will take off and climb quickly, even at higher density altitudes. The extra power of the Rotax 912 is also evident in cruise. At 75% power, the Pulsar XP cruises at 140 miles an hour, 10 miles per hour faster than the standard Pulsar. At this speed, fuel consumption of the Pulsar XP is an incredible 3.5 gallons per hour. With full fuel and 400 pounds of cabin payload, range is 600 miles. Even with the extra weight of the Rotax 912 engine, the Pulsar XP retains the docile and safe slow flying characteristics of the standard Pulsar. Typical approach speeds are 60 to 65 miles per hour. Stopping distances of 800 feet are possible at maximum weight, 400 feet if flying solo. Making the first turnoff is never a problem when flying the Pulsar XP. Strong takeoff performance, fast and efficient cruise, safe approach and landing speeds. This is what flying either a standard Pulsar or a Pulsar XP is all about. And don't forget the most important feature of all. Flying either Pulsar is just plain fun. Whether your choice is the standard Pulsar with the 66 horsepower Rotax 582 or the Pulsar XP with the 80 horsepower Rotax 912, both aircraft share several pilot and passenger-pleasing features. The most important of these features are as follows. Both the pilot and passenger in a Pulsar enjoy superb visibility from an optically correct sliding bubble canopy. In flight, this visibility is really appreciated. There are no high wings, struts, or door frames to obstruct the view. Good visibility equals safety. In a Pulsar, everyone enjoys a clear and safe view of the outside world. In addition to providing excellent visibility, the one-piece canopy makes entering the Pulsar very simple. From the ground, the canopy is slid forward and baggage can be stowed. The pilot and passenger then enter the aircraft by stepping onto the wing and into the cabin. Once seated, the canopy easily slides back and is latched at a single point. Once inside a Pulsar, pilot and passengers enjoy outstanding levels of comfort. provided by the 37-inch wide cabin. Additionally, the seats in the Pulsar are inclined to a 30-degree angle, similar to those found in current jet fighter aircraft. This seating position results in very even weight distribution between the back and legs. Long trips in a Pulsar are very comfortable. A large baggage compartment accessible from the cockpit is also provided. The outstanding in-flight maneuverability of the Pulsar is further enhanced by the use of a center-mounted side-stick controller. Again, incorporating technology currently used on jet fighter aircraft, the center-mounted side stick allows for precise and accurate fingertip flight control. Sitting in and flying a Pulsar is similar to operating a military jet, but with the safety of 45-mile-per-hour stall speed and the economy of 3.5 gallons per hour of fuel consumption. The instrument panel can be arranged to incorporate a wide variety of avionics and instruments. Equipment required for basic VFR capabilities through limited IFR operations can be installed. For ground operations, the Pulsar incorporates a free castering nose wheel with differential braking for steering. An optional conventional type landing gear configuration is also available that utilizes a steerable tail wheel. With either the nose wheel or tail wheel landing gear, taxiing a Pulsar is stable and precise. High crosswinds and gusty conditions are no problem for a Pulsar. The quick control response, low tapered wing, and moderate wing loading keep the Pulsar flying in conditions that might force many light kit planes to stay on the ground. Another important feature of the Pulsar is the ability to remove the wings for trailering and storage. Overlapping main wing spars are incorporated with high-strength attachment pins for easy wing removal. Removing each wing is simply a matter of pulling these main spar pins, disconnecting the aileron and flap control tubes, and unbolting the aft spar. Without fuel, each wing weighs only 50 pounds. To reinstall each wing, the main spar is reinserted into the fuselage and attachment pins are reinstalled. Then the flaps and ailerons and aft spar are reconnected. From on the trailer to ready to fly in 20 minutes. That's all that is required to keep your Pulsar at home and avoid high hangar fees. A great recreational airplane, a practical cross-country performer, modern features and benefits. We've seen why the Pulsar is such a popular personal airplane. Now, let's look at the details of a Pulsar kit and find out what it's like to build this superb flying machine. The Pulsar kit is shipped very complete. All hardware and composite components required to build a complete airplane are included in the kit. All composite components are pre-molded, pre-shaped, and pre-trimmed. All mechanical hardware is ready for assembly. No machining whatsoever is required. Instruments for basic VFR flight are also included. The only items not included are interior fabrics, exterior finishing materials, and a battery. All kit components are shipped enclosed and protected in a wooden shipping crate measuring 16 feet long, 42 inches wide, and 45 inches high. With a complete Pulsar kit inside, the crate weighs approximately 1,000 pounds. After receiving the container and unpacking the components, you are ready to begin building. Basically, the job of constructing a Pulsar airframe consists of mixing structural epoxies and then using these epoxies to bond pre-molded composite components together. All epoxies used in constructing a Pulsar are supplied as two parts, a hardener and a resin. Using a simple balancing device made from instructions included in the construction manual, the proper amounts of hardener and resin for each particular job are measured according to weight. Once the proper amounts of hardener and resin are obtained, they are thoroughly mixed together to form the final epoxy used for bonding. In several applications where added thickness is required, micro balloons are mixed in with the epoxy. This added thickness is needed when the bonding of two composite pieces requires the application of a standing bead or fillet of epoxy, shown here in the application of an epoxy fillet between the seat back bulkhead and the fuselage shell. The first major assembly bonded together in the construction of the Pulsar is the fuselage. After applying an epoxy bead on the bonding flange of one of the fuselage shells, the two halves are matched together. Note that there is no tooling required in this or any other construction process with the Pulsar. All composite components are self-aligning. Only two wooden holding slings are required to steady the fuselage as the epoxy cures. Once the two fuselage halves are joined, strips of masking tape are stretched across the joint to hold the two components together while the epoxy cures. After approximately 8 hours of curing time, the tape is removed. After the two shells have cured, the fuselage is completed by installing several bulkheads and structural stiffeners inside. All of this internal fuselage structure is cut from flat composite sheets provided in the kit. In areas requiring exceptionally high strength, demonstrated here by the seat back bulkhead, the structure is first bonded into place with a bead of epoxy. Then one layer of epoxy and fiberglass is placed over the original epoxy bead. After curing, this double bonding process results in an incredibly strong structure. Remember, the Pulsar has been tested to +6 and -4 Gs. The other major airframe component to be built after the fuselage is the wing. Again, as in the fuselage, the construction process involves bonding pre-cut and pre-shaped composite pieces together. The only support required to build the wings is a flat table at least 10 feet long. The all-composite main spar is set flat on the table, and the pre-cut leading edge ribs are installed down the length of the spar at 8-inch intervals. A square is used to make sure the ribs are positioned at 90-degree angles to the spar. Epoxy mixed with microballoons is used for this bonding process. After the leading edge ribs have cured, a bead of epoxy is put on the outer surface of each rib prior to installing the wing skins. 1/16-inch thick aircraft quality birch plywood skins are then placed over the leading edge ribs and bonded into place. After covering the leading edges, the installation of the remaining wing structure aft of the main spar is accomplished. The pre-cut and pre-shaped wing ribs are positioned and bonded at the same 8-inch intervals on the main spar. After curing, the aft spar is positioned and bonded on the trailing edges of the ribs. Finally, the remaining birch plywood wing panels are bonded over the wing structure. To finish the wing, one layer of 1.4-ounce fiberglass is laid over the entire external surface. This seals the wing and prevents moisture from contacting the wood skins. This fiberglass surface is then filled, sanded, and painted. A new option designed to reduce wing build time is a set of all-composite wing skins. These composite wing skin panels are pre-shaped and ready for installation. They replace the birch plywood skins of the standard kit and save 2.5 pounds of weight per wing. Structural integrity is unchanged. The wood skins and the composite skins have the same structural strength. However, the primary advantage of the composite wing skin option is saving build time. Without the need to trim, form, and cover the plywood panels of the standard kit, a beautiful wing surface ready for final finishing can be obtained in much less time. At least 100 hours will be saved by using the composite wing skins. All processes in building a Pulsar are detailed and illustrated in an extremely well-written and easy-to-follow set of construction manuals. 4 complete manuals are included with each kit. The manuals are generated by computer for added accuracy and clarity and are written with the first-time builder in mind. Even though the construction processes are simple and the manuals are well written, you are certain to have questions during the building of your Pulsar. To help you with these questions, we provide outstanding builder support from our factory in San Antonio, Texas. You will always have access to 2 customer support specialists whose primary responsibility is to answer your questions and give you technical support. You will find our support specialists are hands-on technicians who have personally built a Pulsar. Their practical experience is some of the best in the industry, and they are only a phone call away. From in the crate to a flying Pulsar, it's a job that you can do. the actual documented build time of all Pulsars now flying has averaged 1,000 hours, from opening the crate to making the first flight. And remember, our commitment to you is to get you off the ground and into the air. Aero Designs is not in the business of just selling kits. Everyone at the factory is dedicated to helping you turn your dream of owning and flying your own airplane into reality. So, that's a look at the Pulsar, the airplane, the different models, the features, and the construction processes. But what we didn't talk about was the most important part of building and flying a Pulsar, and that is you. Some people watch life pass them by, not getting involved in activities they've always wanted to do. Other people give up on their dreams because of outside influences they feel they can't control. The project of building and flying a Pulsar can be one of life's most rewarding experiences. It's a chance for you to get actively involved in personal aviation. It's a chance for you to turn your lifelong dreams of flying into reality. The feeling you will experience when you are finished and flying your Pulsar cannot be explained. It is a feeling of tremendous accomplishment, of personal freedom, of pride in yourself and your abilities. The end result is a practical, economical, and unique airplane like no one else's. And you created it. If you are seriously considering a kit-built airplane, we invite you to take a very close look at the Pulsar. What you will find is not only a superb airplane, but a wonderful family of Pulsar builders, pilots, and factory employees. People who really care about you and your project. And when you finish, you will have the thrill of flying the best performing, most exciting, and highest value kit-built airplane available today, the Pulsar.